Alright, let's start by taking a look at the periodic table. We're going to zoom in real close and get to beryllium. Alright, now we are looking at beryllium. Beryllium on the periodic table has an atomic number of 4, which means it has 4 protons. So we know that any atom that has 4 protons is beryllium. So we know the number of protons. What about the number of neutrons? Alright, so to figure the number of neutrons we have, we're going to look at our atomic mass, which is 9.0122. The atomic mass is always the bigger number. We're looking at the atomic mass. We're looking for the number of neutrons. So the atomic mass is the number of protons plus the number of neutrons. So we know our number of protons is going to be 4, because it is the atomic number. So we have a simple algebra problem to do. We know 4 plus the number of neutrons is going to equal 9.0122. Let's set up our algebra problem. Now we can take 4 from both sides to solve for n. Now we know that the number of neutrons is going to be 9.0122 minus 4. This gives us a number of 5.0122. Because it is impossible to have 5.0122 neutrons, we are going to round down to 5. So our total will be 5 neutrons. Now we know that a beryllium atom has 4 protons and 5 neutrons. For a neutral atom, we will have the same number of protons as we do electrons. To see that it's neutral, we can start by adding up all the protons as plus signs, and then the electrons as minus signs. We can see here that there's the same number of protons as there are electrons. Because we have the same number of protons and electrons, they are going to cancel each other out, leaving us with 0 charge, because it is a neutral atom. What would we need to do in order to make it positive and not neutral? First, let's try adding an extra proton to have 5 protons in total. Now we have a positive charge. If we subtract the number of electrons from the number of protons, we get plus 1, which is a positive charge. Unfortunately, we cannot change the number of protons. Let's see what happens when we add a proton to a neutral beryllium atom. Look at the net charge change. It is now a positive ion. However, it is no longer beryllium. It is something different. It is boron. We want a positive beryllium atom, not a boron atom. Take that proton back and try something different. Now let's see what happens when we take an electron off. You can see the net charge has changed to be plus 1. We can move electrons around however we want, so we can take them away or add them. We just can't change the number of protons. Take the other electron off too. Now we have a positive charge of plus 2, which you can see in the net charge window to the right. Now let's see what happens when we add electrons. When we add up to 6 electrons to our atom. Every time we add an electron, the atom gets more and more negative. Watch the net charge window to watch it happen. We can never change the number of protons without changing what atom it is. We can only ever create charges through electrons. How would you figure this out without the simulation? The best way is to count. For example, if we have 4 protons and 5 electrons, we have 4 pluses and 5 minuses. That will give us a total charge of -1. What if instead now we have less electrons? We'll have 4 protons and 3 electrons. You can add up the pluses of 4, and you have 3 minuses. There's 1 more plus sign, so your charge is plus 1. We can also show this using math. Let's take the number of protons and subtract the number of electrons. If this number is bigger than 0, we have a positive charge. Our positive charge is going to be P minus E. If instead the P minus E is less than 0, that means the charge is negative. There are more electrons than there are protons, and the number of the charge will be P minus E. Let's talk about some special electrons. We call them valence electrons. Valence electrons are the amount of electrons on the outermost shell. Atoms want to fill their shell. The first shell is 2, the second shell is 8, and the third shell is 8. So whichever one is the outermost one, that's what the atom wants to fill up or give away. Take a look at hydrogen. You can see it is neutral. However, it does not have a full outside shell. Hydrogen doesn't want to have any valence electrons, so it's going to try to get rid of that electron real fast. Because hydrogen loses its electron, it becomes a +1 ion. An ion is an atom with a charge. Let's take a look at another atom, a lithium atom. It has 3 protons and 3 electrons when it is neutral. However, it does not want to have that one outside electron. It is going to try its best to get rid of it. And so when it loses that electron, it's also going to become a positive ion. Now its outermost shell is empty because it has 2 electrons. Also, now lithium is a positive ion. It has a +1 charge. Let's take a look at nitrogen. Nitrogen has an atomic number of 7. Nitrogen needs 3 more to have a complete outer shell, as it only has 5. It is 2 in the middle, but those don't count towards valence electrons. So when we add 3 more electrons to the nitrogen ion, it becomes a -3. To find the charge, there's a much easier way to do it. We can look at our periodic table and see that column 1 will form +1 ions, column 2 will form +2 ions, then go to 13, we'll plus +3, 14 will do plus or -4, 15 will do -3, and 7 does -1, and last but not least, noble gases is 0. So on the left side of the table, we see positive numbers. We call these cations because they are positive. So anything on the left side of the periodic table, or the 113, is going to be positive. On the right side of the periodic table, however, we have negative numbers. We have anions.